So question one is on theory of. You'll be given tables like this, and you'll be asked to tabulate the average revenue, marginal revenue, profit, marginal cost, and the average cost. So it's important to remember what marginal cost is. Colleagues, do we remember what the definition of marginal cost is? What is marginal cost? Oh, thank you, Mr. Manaza. I'll go through the notes and I'll make a lesson plan for it for them. Thanks for that. Yes, what is marginal cost, colleagues? Ooh, okay. In economics, whenever you hear the word marginal, it just means addition. So this is the additional cost you incur whenever you produce one more unit, right? The additional cost you incur when you produce one more unit, all right? What about marginal revenue? If marginal cost is the additional cost, produce one more unit, what is marginal revenue? Colleagues, exams are coming approaching the corners. It's good we participate in class that we see where the understanding is and where it isn't. If marginal cost is the additional cost you incur by producing one more unit, what about marginal revenue? Mhm. What you get by selling one more unit. Okay, so then what about average revenue and average cost? Average cost, this is the cost of one unit. So what about average revenue? The revenue for each unit. The revenue each unit brings, right? Whenever you hear average in micro, just remember it's just per unit. All right. Okay. So with this table, as I said, you have to be aware of the formulae to get average revenue, marginal cost, and average cost. All right. Average revenue formula for it is average revenue AR equals the total revenue divided by number of units. Then marginal revenue is the change in total revenue over the change in quantity. The change in quantity, yes. For average cost, formula is total cost over quantity. Then marginal cost is the change in total cost over the change in quantity. So please get these down because in the exam you're likely to encounter such a table. My screen is not visible. I'm sharing my screen. No, just I've wrote here the four. I've put four formulae on the screen. Okay, so it's important that you get these formulae down, and these are the formulae that we're going to use on that table. Then profit, it's total revenue minus total cost. So, for example, let me see. Let me get this table. Now, so, for example, at 0 units, average revenue, you say total revenue zero divided by output, you get 0 units. Here, there's not going to be any marginal revenue because we do not have anything before this. So here you won't have any marginal revenue. All right. Profit, total revenue minus total costs, 0 minus 20. The profit is negative 20. Marginal cost, there won't be any figure here. Average cost, total cost 20 divided by output, it will be 0 here on average cost. Oh, I actually have the table even. All right. When we come down to 1 unit, the average revenue, say it's total revenue divided by quantity. So 100 divided by 100. Marginal revenue, we said change in total revenue divided by change in the quantity. So when we say change in total revenue, we're going to say this 100 is our TR2, this 0 is our TR1. So you do it like this. marginal revenue. So we're going to say TR2 minus TR1 over Q2 minus Q1. So if we look at the table here, we'll say our TR2 is 100, TR1 is 0. Then our Q2 is 1 and our Q1 is 0. So marginal revenue 100. Are we okay with that tabulation here? Profit, total revenue 100 minus total cost 60, 40. Marginal cost, change in total cost. So you're going to say TC2 is 60 and TC1 is 20. So we just represent it like this. Marginal cost TC2 minus TC1 over Q2 minus Q1. TC2 was 60, TC1 is 40, Q2 is 1, Q1 is 0. 60 minus 40, that is 20. 20 divided by 1, that is 20. Or 60 minus 20, that is 40. So here it's 20. TC1 is 20. So 60 minus 20, that gives us 40. Which is here. Are we okay with this tabulation? Okay, then average cost, total cost, 60 divided by quantity, that is 1. So 60 divided by 1, that is 60. All right. So those are the same formulae you use to get all these other figures. So any questions on this table? The other formula you need to know, total cost equals fixed cost plus variable cost, and average total cost. All right, the total cost per unit is total cost. Oh, we've already done average total cost. I've already given you for average cost. Or average cost, average total cost, the same thing. But if we say average variable cost, Average variable cost, it's our total variable cost VC divided by quantity. Average fixed cost, so total fixed cost FC divided by Q. Yeah, these are the other two which the other three formulae. Sometimes they might put fixed costs, variable costs. It depends. The tables are not standard. They might. Yes. So these are the formulae you need to deal with such tables in microeconomics. If there's no question, we can look at the next part of question one. We'll plot the data all on one graph. It was good that we have Excel. This is how your graph should have looked. So many lines to be confusing, so we need to we'll look at each cost graph individually because here there are so many. We'll break them down one by one. Huh? Determine the profit maximizing output and confirm that at this output, marginal cost equals marginal revenue. So this point where marginal cost equals marginal revenue, this is the point at which the number of units where marginal cost equals marginal revenue, it means with those, if you sell those units, you're going to have your maximum profit. If you go beyond this point, MC equals MR, you're going to start making losses. Oh no, no, I'm just explaining the concept of margin. Yes. The graphs will come to them. Do not worry. Okay, let's just do with the first the calculations. Then we'll focus also on the graphs. But right now, what I'm explaining is this point. Point where MC equals MR. So this is the point of profit maximization. As I said, if you go beyond this point, you're going to start making losses. Because beyond this point, marginal cost was going to be greater than marginal revenue. Okay. If you produce any more units, it will cost you more to produce them than the revenue that you get for selling that unit. Then if you produce beyond this point, all right, you are still going to make profits, but the profits are going to be less than the profit that you make at this point. Right? Any points before this point, you're going to make profits, but those profits are not going to be greater than the profit that you make at this point. That's why the firms choose to produce where marginal cost equals marginal revenue. So we go to our table and we're going to see, as we look, what is the highest profit that can be made by this company. The highest profit is 70 kwacha. All right, so here at 70, is it at the point where marginal cost equals marginal revenue? Yes, it is. Here marginal revenue is 60. Marginal revenue is, marginal cost is also 60. You can also argue the firm can also produce 2 units, because still at 2 units, the profit will still be its maximum. But here we'll go for this 3 units, because at this point, MR equals MC. So the number of units this firm should produce to maximize its profits is 3 or 2. Because with this number of units, it will make a profit of 70. Any questions? Question 2. Suppose the cost function of a firm in a perfectly competitive market is given by this TC equals 10 plus 2Q squared, and the market price is 40 kwacha. Okay, maybe we can talk about perfect competition. This is the first market structure. All right. The characteristics of a perfect competition. All right. The first characteristic, all sellers are selling the same type of good. All right. Homogeneous. The good is homogeneous. It means it's the same good being sold by different sellers. For example, the tomato market. All right. Everybody is selling tomatoes. All right. And tomatoes are not different. Okay. So that's the first characteristic of a competitive market. Firms are selling the same type of goods. The second characteristic is customers are well aware of prices, right? They have perfect knowledge of prices, so that if a seller tries to increase the price, that customer knows already the price of that good, and they're going to go to the people who are selling that good at that certain price, right? Let's still think of the tomato market. Everyone knows, ideally, okay, ideally, because remember, these are models, it's not perfect in real life, but ideally, the way this model is working is that, let's say, in the tomato market, all right, one tomato is going for 1 kwacha. So, as the customers, we are all aware that a tomato is 1 kwacha. If anyone tries to sell you a tomato for 2 kwacha, you are not going to buy, because you think they are trying to scam you. All right. So customers have perfect knowledge of price. Oh, you also did this during the recitations. Colleagues, what are the other characteristics of a perfect competition? Those who are there during the residentials, what are the other characteristics of a perfect competition? Hmm. Okay, easy entry and exit into the market. So let's think of the tomato market. Anyone can just buy a box of tomatoes and start selling tomatoes. Okay, easy and easy entry and exit. What else? What else? Anybody? At least you must have remembered one characteristic. Yes, large number of sellers, right? Large number of sellers. There's one more important characteristic which I haven't listed here, and I'm hoping someone can say it. Hmm, market shares for oligopoly. Yes, firms are price takers. Thank you very much. Firms are price takers, meaning they cannot decide and change the price. Price is dependent on the market forces which affect the growing of tomato and its distribution of it. So you would say firms are price takers. And in this type of market structure, demand is perfectly elastic. Colleagues, what do we mean by that statement when we say demand is perfectly elastic? Meaning, when you calculate the PED, price elasticity of demand, you get infinity. What do we mean when we say demand is perfectly elastic? Remember, we looked at price elasticity of demand. Mm. Just erase that part of the downward slope, but you are in the right lane. Um, Ish, you are breaking. I couldn't hear you. But okay, perfectly elastic, meaning network is breaking. Let me just say it. But you're going in the correct, you're in the correct lane. Yes? Yes. Very, very. Let's add very. Hmm. Let's add very, very sensitive. Okay. Because when we say perfect elastic, when we say demand is perfectly elastic, ideally what we mean is consumers are paying one single price for that commodity. So if anyone tries to raise the price, no one is going to come to buy from them. Okay? No one is going to come. Like in the tomato market, just think tomato sellers in a group. Each tomato is going for one kwacha. Then maybe one of the sellers tries to increase and say, okay, my tomatoes are going for two kwacha. No one is going to come to that stand for theirs. They'll just go to the other people. So any increase in price, there's going to be demand can even reach zero due to an increment in price. Demand can reach zero. Then if you reduce the price, right, it means everyone is going to come flocking to you. As we said, tomato sellers, each tomato one kwacha. If one person says now I'm selling tomato at 15 ngwe, people are going to stop buying from those who are selling at one kwacha, and they're going to come to the person who's selling at 50 ingwe. So it'd be like that person has captured the whole demand. So price is very sensitive. That's what we mean when perfectly elastic. Right? Quantity demanded respond at a great extent to its very small changes in price. Even a 1% change in price, quantity demanded can even drop by 100%. Okay? Quantity demand is very responsive to very small changes in price. Okay, now back to this question here. All right, we have the total cost function. Colleagues, what do we mean when we say a function? What is a function? A function shows the relationship between two variables. So here, this function here is showing the relationship between cost and the quantities produced. TC equals 10 plus 2q squared. All right. So we want to find the marginal cost. All right. So here we're going to have to use differentiation. All right. Remember when we said marginal cost equals TC2 minus TC1 over Q2 minus Q1. Then this is going to change to into this. Change, oh, not change, but DTC over DQ. And basically, what we're just saying is we're differentiating this total cost function with respect to Q, meaning Q is our main variable here and is the one that we'll be using for the power law of differentiation. Differentiation just measures the rates of change. All right. So this formula has transformed into this. All right. So, colleagues, do you remember how to differentiate from that previous lesson we did? Well, differentiation. Okay, so differentiation is easy. You just get the power, you multiply it by the number in front of the letter. 2 times 2, that is 4. Then this same power, you subtract 1 from it. 2 minus 1, that is 1. All right. And then, as I said, numbers without variables disappear. They disappear. So, this is our marginal cost, 4Q. All right. Any questions? So remember, we said marginal cost. This is the additional cost for every unit that you produce. So you can start with 1 unit. What would be my marginal cost? 4. With 2 units, 8. With 3 units, 12. With 4 units, 16. All right. The additional cost that you incur for extra unit that you produce. Any questions before we go to the second part? Mr. Aaron, any questions? Mr. Tapewa, Madam Teresa, Madam Natasha, Mr. Marvelous. Okay, wonderful. Okay. Derive the total revenue and the profit functions. All right. So always remember this formula for total revenue: price times quantity So we've been given the selling price 40 kwacha. So times Q, that's going to be 40Q. So with these questions, always remember this formula. This one too. Which other one? Yeah, this one. Because other times don't give you the total revenue function. You have to get it by yourself. Like in here, you have to get it by yourself. Then we have to get the marginal revenue. We are deriving the total revenue function with respect to Q. So colleagues, when we derive this 40Q, what is our answer? If we derive 40Q, think of this as 40Q to the power 1. So that's a marginal revenue 40. So when you sell one more good to annual an extra 40 kwacha. So another good 40 kwacha. Another good 40 kwacha. Profit function, remember profit equals total revenue minus total cost. Total revenue 40Q minus total cost 10 as 2Q squared. We're going to have 40Q. We distribute this negative sign, and negative 1 times 10, we get negative 10. Negative 1 times 2Q squared, we get negative 2Q squared. So this is your profit function. Then if you want to know how many units should I produce to maximize profit, that's what you say. Marginal revenue equals marginal cost. Want to know how many units do we need to produce so that we can get the maximum profit? Marginal revenue is 40. Marginal cost was what? 4Q. All right. Divide both sides by 4. Q equals 10 units. So if we produce 10 units, we'll have our maximum profit. Any units below, our profit will be less than the profit would have got 10 units. Any units above, we'll start seeing losses. Or the profit first will start reducing slowly, slowly, slowly. That's when you now start entering losses. Yes. Now, for the, I think there was a part which asked for the to get the mark the what do you call this? What level of output should be produced to maximize profits? It is that's where we did this. MRI equals MC. Then the next question was how much profit will be earned? So you substitute Q for 10. Right. Now I have to switch to the second years.